Hello and welcome to our webinar From Zero to Cloud in 60 Minutes. My name is Sarah Bacon. I will be your host for today. In this webinar, we're going to show you step-by-step how to build a multi-tiered application in the cloud in less than 60 minutes. So, man running the show, Alon, he's our technical trainer at RightScale. He is an amazing, brilliant man, and you will be very fascinated by this presentation that he has in store for you today. And I'm going to just stop talking in a second so we can get forward with that. One thing I'd like to point out for you, though, is Chris Williams. He's on our Q&A line. So what that means is you can use the GoToWebinar questions panel to ask questions at any time, right now or 5 minutes from now or any point during the presentation. So Chris will be answering questions as they come in. A few of those we might select for Alon to answer live over the air if they're directly applicable to that particular point in the presentation. So go ahead, ask your questions, we'll get them answered. And with that, I'll pass it off to Alon to go ahead and get started.
Okay, hello everybody. What we're going to do here in the next hour is we're going to create what's kind of known in the industry as a three-tier deployment. And this is kind of a standard web-based architecture where you have two load balancers, some number of PHP application servers or any kind of application server in the middle tier, and that's scalable, so you could have 2, 10, 100, 2,000, however much is needed. And then in the third tier, we have a replicating master and slave database. So we have a master database, but it's continually replicating to a slave database as a hot swappable slave. So if your master database dies, you've got a slave database and you could be up and running in just a few minutes. And those are making continuous backups as well, so that even if both databases were to crash, you would have backups available that you could restore from. And so we'll go through that whole process, and then at the end, we can have some Q&A, you can ask some questions, and we'll see if we can get them answered. Okay, so just as kind of a basic is the way the web works, is you've got a browser. When you make a request, let's say you're going to go, you want to buy an airline ticket, and so you type in united.com. When you make that request, DNS resolves that IP address for you, so your browser knows where to go. And it goes to through a load balancer, and the load balancer will then choose which application server it wants to send it to, because there may be multiple application servers to handle the load. And so it picks one, and it shares the load so that it can distribute the load throughout all the application servers. The application servers presents you with a page that says, okay, where do you want to go and what dates do you want to fly on and all of that. And then when you type in, I want to go from here to there on this date, and you hit the button, well, the application server now communicates with the database to get the actual information of all the flights and the prices and all that. The database returns the information to the application server, and then the application server creates the page that actually has the information for you, sends it back through the load balancer, back to your browser, and now your browser can display all your flights. So how this is going to look, kind of real scenario is at the top we have the browser looking at DNS, connecting to DNS to get there to resolve unitedairlines.com into its actual IP address. You can see it's going to one of the two load balancers that we have loaded here. You can have more load balancers, but we've got two. Okay, and then the load balancer chooses which application server it wants to send the traffic to. And you can see there's app 1, app 2, and app n, because we don't know how many there's going to be. It can be any number depending on how many are needed. Those application servers are connected to the database. The database actually has its data stored on these are EBS volumes. And the EBS volumes, it's like a storage area network, are making backups onto S3. So these are compressed snapshots stored up in Amazon's S3. This particular session is Amazon specific, just because that's the largest cloud out there right now. But any of this technology is applicable to any of the clouds that will support it. And so there are many other clouds growing right now. So soon this type of demo would actually have multiple clouds, and we'd be scaling between different clouds. And that's maybe even in a month or two when we do this demo again, for some people it'll have that hybrid cloud solution. Okay, so with that I'm going to close PowerPoint for now, and we're going to jump right in to the demo. Okay. So there's a question about what is the use of the load balancer. I think that was answered, but the idea is to share the load amongst all the application servers. It also handles if an application server goes down, crashes for some reason, the load balancer can detect that, and it can take the, that application server out of the pool, so it doesn't send traffic to that application server anymore. So it not only load balances, it gets rid of any bad application servers. Okay, so I wanted to show this really that when we start, I'm starting with nothing basically, right? I'm starting with a little bit of code, a little bit of PHP code that is for my application, so I have something to show you, and a very simple database table. But I've got nothing else. There's no smoke and mirrors. I haven't created anything in advance, so I'm going to create every single thing for you right now. The question is that, is S3, is that a reference from AWS? And yes, it is. Amazon's S3 is like a global hard drive the entire world shares in a way, and you can create what are called buckets in S3. It's a great location for storing backups, flat files. If I want to store if I want to share a 200 megabyte file with somebody, I don't use FTP servers anymore. I would upload it to S3 and they could download it from S3. I can give them a URL and they can download it. I'm going to use it because that's where I'm storing my PHP code and my database table right now. Okay. And HA probably does support session stickiness. In fact, I'll have to set that. I'll probably turn that off because I want to be able to go. Session stickiness is going back to the same application server every time, and I want mine to a different application server. So. Okay. Question is, why do I need 2 load balancers? For this example, I really don't need 2 load balancers. It's just that a typical example, you'd have a typical deployment, you would have 2 load balancers. So if one dies, the other one is still available, and it also, it shares the load between the load balancers because DNS will give half of the people 1 load balancer as their first try, and it'll give the other half of the people the other load balancer. So out of 1 million people, 500,000 will go to load balancer 1, 500,000 will go to load balancer 2. So it shares the load amongst the load balancers as well. Okay, so I have under here in S3, it's my S3 browser, and this will be very fast. This is basically a 3-day course compressed into an hour. I've got 2 buckets. One is called V2C for Zero to Cloud app for the application, and in there you can see I've got a little bit. It's a myapp.tgz. It's only 453 bytes, so it's not much, right? It's just a little bit of PHP code. And I've got another bucket called V2CDB for the database, and I've got a single database table, and you can see it's only 761 bytes, so it's really not much there. Okay. That's all I'm really starting with. So what I'm going to do is first I'm going to create a deployment. A deployment is like a logical container where we can control how we can have our servers. So imagine if you had 50 servers in production and 50 in staging and another 50 in QA. It's 150 servers. The cloud sees 150 servers, but we know they have 3 different purposes, and so we want to be able to separate those so we can like shut down all of the staging servers without even touching production. And so I'm going to create what's called a deployment. It's a RightScale concept, and in there I'm going to place all of my servers. So we'll call this the Zero to Cloud deployment, okay? And to start with, there are no servers, okay? All right, so got the deployment. Now I'm going to bookmark this deployment. And by bookmarking it, I can get back to it easily, so I'm going to add a bookmark. Right now, I think I can always get back to my specific deployment easily. All right. The first thing I need to do is import what are called server templates. So the way we create a server is we have, it's like a blueprint, right? A blueprint of the server. And so within that blueprint is all the configuration information for that server. So if I want to launch a database, rather than have to spend hours downloading it, untarring it, and configuring it, installing it, I can use RightScale's pre-configured templates. We've basically looked at what do customers mostly need, and we've created templates around that, so you can launch a database in about 7 minutes instead of many hours. So I'm going to go to Design, multi-cloud marketplace server templates. And this is where you can find server templates. And the first one, let's start with the top down. I'm going to go for my HA proxy. This is my load balancer. Okay, and there it is, RightScale load balancer with HA proxy. And I'm going to import it from the RightScale library. So I'm going to bring it into my account. And it takes a few seconds, so I'm going to open up a couple of windows, and I can run through this all at one time. So the next one I want is the PHP application server. So I'll type in PHP, and let's look for, here we have PHP app server 11h1. This 11h1 is just a compatibility, so I know it works with other scripts that are also called 11h1. So let's look at that, and I'll import it. It's another server template. Okay. I'm going to get one for my database. So I'll type in MySQL. And I'm going to use Database Manager with MySQL 5.0 11h1. Okay, so I'm using MySQL 5. So I've downloaded all three, well, not yet, here we go, import. I've downloaded all three of the server templates that I need for the three different types of servers that I'm using. I'm going to download one more, and this is so I can have a load tester, because at the end of this, I want to throw some load on it so I can watch these servers scale up. So I'm going back to the multi-cloud marketplace, server templates, and it's called HTTPerf. Okay. And there it is, so I'll import that. So I've got all four server templates in my account now. So if I go to, once this is imported, okay, now if I go to Design Server Templates, you can see there's my load tester, there's the database, there's the app server, and there's the load balancer. So I have all the server templates, and I can build the servers from these very easily. So I need to create some objects in the cloud. So I'm going to Amazon US East, and the first thing I need is an SSH key. And notice I have no SSH key, so I'll click New, and I'm creating a new SSH key. I'll call it 02 Cloud. Okay. This will create an SSH key for me. Then all I need to do is when I create a new server, I can choose this specific SSH key. And that way I can SSH into the machines, and the machines can talk to each other as well. Okay, so it's done. I don't have to do anything else. I could take this if I wanted to, and I could copy it and generate a public key from it and all of that. No real need to, though. Okay, the next thing I'm going to do is create a security group. This is a firewall. I want a firewall so nobody can come in to my servers unless I give them permission. So I'll hit New for a new security group. Let's call this 02 Cloud Security Group. Okay. By default, now every server has to be inside of a security group in Amazon. By default, the permissions here are none. Okay. And so what I'm going to do is start opening up holes because I need people to be able to access port 80, right? So you can see now it says on TCP protocol, any IP address can access port 80. I'm going to open up 443 as well for secure HTTPS. Okay, there's someone on there. Let's try that again. Okay, and I'm going to open up port 22 so I can SSH into my machines. Now, normally you may not open this up to the whole world. You can get more granular with your security. But for this example, I'm opening up 22. Okay, I'm going to allow the group to talk to itself. Basically, the security is so tight within Amazon that the servers within the group wouldn't even be able to talk to each other if I don't allow them to. So this step has just allowed the servers, like the load balancers and the app servers, to talk to each other. And the last thing I'll do is I'll enable ping, so we can ping the machines if we want to. Okay, how are we doing here? Ping for anybody. The group can talk to itself on these ports. We have 22, 80, and 443 open to the world. So I have a good secured group. Any server I place in this security group should work the way we want it to. Okay, question is it possible for AWS to have 2 load balancers in 2 separate regions? My DNS sends a request based on client location in respective AWS region. Well, you're asking for an Elastic Load Balancer. I'm not going to go into Elastic Load Balancer right now. You can have load balancers in different regions. You have some issues you have to deal with as far as SSH communication, because SSH keys only work within a specific region. But yes, you can have load balancers in multiple regions. Just got to work with the complexities. Does RightScale have its own data centers, or do you run in front of Amazon? We run 100% in the cloud. Even our phone system, we have a global phone system on, we span most all continents except Antarctica, and even our phone system runs in the cloud. Everything. So we truly eat our own dog food. Everything runs in the cloud. Okay, the question is, do the templates have RightScale agents installed? Our templates have what are called images, and the images are what allow you to abstract between the different clouds. So if I want to launch an app server in Amazon or in Rackspace or in a private cloud, I can do that because the image at the bottom is specific to that particular cloud, but everything above it is just my Linux software, my application server. And so in that image is something called RightLink, which is our agent that lets control the server and communicate with the server. Okay. All right, so I just created a security group. Okay, now I'm going to create some Elastic IPs. Every time you launch a server in Amazon, it's given a dynamic IP. That's great some things, for other things not so good. Like for DNS, you may not want that. So what I'm going to do is create 2 new Elastic IPs. Okay, and these IP addresses are mine for as long as I want them. EIP1, I'm going to name them so I can see what they are. EIP2, okay. There's mine for as long as I want them, but I'm going to associate these to my load balancers so that these IP addresses are publicly available. And now I need to actually go into DNS, and I'm using a DNS Made Easy. DNS Made Easy is one of the dynamic DNS providers that we support. There's also DynDNS and Route 53 from Amazon, but I'm going to use this one right now. I'm going to create a record. These will be DNS records, and you'll be able to look these up in a few minutes. So my first one is, by the way, my domain is called RightScaleTraining.com. Okay. So www.rightscaletraining.com. Okay. And the IP address will be that IP address of my Elastic IP, this guy right here. Okay. Timeout 1800 seconds, that works. Okay. And so now I have an A record. Right there. Let's create another one. This is also going to be www.rightscaletraining.com. So if you ask for either one of these, if you ask for www.rightscaletraining.com, you'll get one of the 2 Elastic IPs, and it'll be round robin. So I'll get one, you'll get the other, next person gets the first one, next person gets the second one. Okay, now I need to create a couple of dynamic A records, and this is probably the most confusing part of this entire session, so if you don't quite get it, don't worry about it. I'm going to create one for my master DB. The problem is my master database it'll come up with a dynamic IP address, and so nobody can find it. And so this, what I'm going to do is create it such that my master database can log into this interface on my behalf and actually update this IP address to whatever its current real IP address is. And I'm going to do the same for the slave database. Okay. All right, so I have 4 A records. These 2 will be dynamically updated as needed, and these are the ones that are statically set. All right. Now this part might get a little boring, but I need to create what are called credentials. Credentials are values you want to set in one place that can be used in lots of different places. So for example, my DNS password. Lots of different servers maybe want to be able to log into DNS. And so I'm setting these in one location. I have about 10 of these I have to do. Maybe about 10, 15, something like that. I already set these two up because I didn't want to actually expose my DNS username and password. But I'm going to create some new credentials here. This will take just a few minutes. And it doesn't matter what I set these values to be. This is like the replication password. Because we're creating everything new, I will create the database to use this particular username and password. But then again, when I access the database, my servers are going to use the exact same username and password because I created them in one place. So again, I'm using the same value. So it really doesn't matter what the value is, because when my database creates itself, it'll use this value. When somebody accesses the database, it'll use that same value. Now, I like to use credentials any place where I have to set a value in more than one location. For example, what's my host name? All right, it's www.rightscaletraining.com. So I can't screw it up. I can't type that in incorrectly. As long as it's correct here, which it looks like it is, my host name, if I use it, no matter how many times I use it, it'll always be the same. Okay, same thing for my my database schema, right? Database schema name, I'll just call it 0 to cloud schema. Okay. I'll create one for my database lineage. This is lineage name. This is for my backup. So this would be Z2C backups because I'm going to be making backups, and so I have to give them a name. My master database DNS ID, which was this. So my server knows which record, when it logs in, which record is it going to modify. In fact, I'll create one for the slave too. Slave DNS ID is right there. So I'm setting all my values up in advance. That means when I go to launch servers, it's going to be really easy and really quick. Okay. All right. Let's see which other ones I want to create. Oh, health check, so that when my load balancer has to ping the application server every 30 seconds to make sure that it's up and alive, this is the name of the file that it's going to look for. So I have to create that file on my application server. And one more, and this will be for my master host name, master underscore DB underscore host name, and I said that was master DB dot RightScaleTraining.com. Okay, gotta make sure those are correct. Cool. Okay, let's make sure I got all the credentials I need. So there is a bit of setup, but you'll watch when I go to launch these servers, they're going to launch really easily. Okay, I think I've got them all. Okay, let's create some servers now. So I'm going to go back to my deployment. I have my bookmark over on the left. There's no servers in the deployment, so let's add a server. And this is going to be in the US East. That's our cloud that we're using. Amazon has 5 clouds right now, but we'll use US East. And the first thing I'm going to do, I will add the database. So I'll type in MySQL. There it is, right there. Okay. So we're using the MySQL server template, right? The name of the server is MasterDB. The size is going to be, we'll use a 32-bit server, and it's going to be a small, okay? So 32-bit, the i386, small. I have all the choices. I could make it 64-bit and turn it into a 2x large or 4x large. I can go from one to the other in minutes. I could clone one of these, change the size. So there's a lot of options. Meanwhile, I'm going to stick with 32-bit and a small. I'm going to use the SSH key that I created. I'm not going to associate an Elastic IP. Those are for my load balancers, so I'll leave that alone. But I will give it a security group that I created. Okay. I'm going to put this in Zone 1B because, so within US East, the one of Amazon's clouds, US East, one of the 5, it's broken into 4 zones, 1A, B, C, and D. The idea is that the zones are distinctly separate, like different power lines, different, maybe just physically distinct buildings, different networking lines. So if one goes down, the other is most likely going to stay up. So I'm going to put this in 1B, and now I'm done with that. Okay, and finish. Now I just created a server, but it's not launched in the cloud, right? If I look at my deployment, what you can see is I have a master database using this server template with all the instructions on how to create it. Here's the key in the security group. Okay, but this red box says it's not running yet. So I'm going to go in and clone it because I want a slave as well. So I'm going to hit clone. I'm going to change the name to slavedb. Okay, and I'm going to change one aspect about the slave. I want to make sure it launches as a slave, not a master, and so I only have to change one thing here. It's one of these inputs right there. Okay, now I have a master database and a slave database. So one is a master, one is a slave. All right. But the one thing I want to do with this slave, I want to stick in a different availability zone. Notice they're both in 1B. Well, if 1B goes down, all my databases are down. So I'm going to click on the slave now. I'm going to click Edit. And I'm going to change the availability zone to 1C. So the chance of both zones going down in the same time is unlikely and has only ever happened once in the entire time that I've worked in the cloud. And so that I know of. So let's go back and look. Cool, now we have master slave, but they're in different zones. So if zone 1B crashes, the whole zone goes down, I can be using my slave pretty quickly here. Okay. Next, let's create some load balancers. Okay, same process. Add server to the deployment. It's a US East deployment. Okay. We're going to look for the HA proxy. There it is. There's the server template with all the instructions on how to create an HA proxy server. Okay. I'm going to choose my SSH key. Now this one, I am going to associate my Elastic IP, that static IP that Amazon gave me. So from DNS, the one I entered it in DNS, right? It's this one right there, I think, one of them. Okay, so I'm going to choose a security group. The availability zone, I'll put this one in 1B, right? And confirm that. And of course, if I want to now take that server and make another load balancer, I don't go through the same process. I click on the, here's my load balancer. First thing I'm going to do is rename it, because that's a big name, RightScale Load Balancer with Apache. Now, I'm going to click on it. I'll click up in the name, and I'll change the name to Load Balancer 1. Okay. I'll clone it, change the name to Load Balancer 2, and what's the only thing that I need to change? I need to change the Elastic IP, that DNS IP address. So I'll change this guy from EIP1 to EIP2, and I'll change the zone. I'm going to stick this guy in 1D. Okay. Now, if we look at our deployment, we can see we've got, if zone 1B were to crash, well, we still have a load balancer in 1D. Whoops. Sorry. If zone 1B goes down, we have a load balancer in 1D and a database in 1C, so we're good. If 1C 1C goes down, we lose our slave, so what? If 1D goes down, we would lose our load balancer, and that's it. So no matter what zone, if only one zone goes down, we're still good. Okay. You can even have 2 zones go down, and you might be good. So a lot of failover in here. Okay. Next, we're in the deployment, right? We're looking at all of our servers. We have these things called inputs. Inputs are all the values you need to give to the server in order for it to work. And so, because these are not in the server template, because they're unique. Like your name of your database is very unique. And so these are the inputs that have specific values for your particular launch. So I'm going to go through and change them. Now, how do you know which ones to modify? You just kind of do it for a while. After you've done this for a while, you learn which of the values you need to modify. So I created those values earlier. There it is, dbadmin password for the dbadmin password. Right, so now that I've created all the values in advance, I don't have to do anything now with it. Just assign them. This will take just a moment. Whoop. It's a common mistake to make right there. See, DB lineage name for my backups. DNS password, I've already created that as my DNS password. I'm going to use DNS Made Easy as my dynamic DNS provider. Here's my DNS user. My tech URI, that's so the load balancer knows which file it needs to check to see if the server's still alive. It'll be hostname. I created one called hostname. Master database DNS ID, right? That was the dynamic ID, so it knows which server to go, which line to go update. And also my master database hostname. And you can see what script they're using if you want to. Here's the private SSH key to install in the servers. My slave DNS ID, we're at the bottom of the list almost here. And last line is what is my website DNS, which is under hosting. Okay, so I will save that. Now what I've done is I've saved inputs in the deployment. Any server I launch in the deployment, which we have several, right? We have 4 right now. Any server I launch in the deployment will take those values. So now watch how easy to launch a server. Click on my load balancers and my master database, choose launch, hit apply to selected. And it says anything that, do you want to launch them? I say yes, and that's it. So because I set everything up in advance, I can just launch them like that. All right, so while that's launching in the background, because that'll take about 8 or 9 minutes for all those servers to launch and become operational. All right, so what we want to do next here, I'm going to make my application server. So if we go back here, what I've done so far is I've created the load balancing tier. I've created the database, the master database, and it's launching. Now I need to create this middle tier, the application tier. And you see right here, and you can look on the left, see it says pending. That means we're asking Amazon for an instance. Then it'll go to booting, where we're going to run all of our scripts that install all the software and configure it, and then we'll be what's called operational. Okay, so I'm going to create an array. Because that middle tier scales up and down, I don't add it like I did these other servers. I create an array, give it some other instructions on how to scale up and down, and then we can add that to this deployment. So I'm creating a new array. I have no server arrays to start with. I'll create a new one. This will be in US East in my 0 to cloud deployment. Okay, I'm looking for a server template, right? And I created the server template. This one right here, the PHP app server, that's the one I downloaded. So these will be my app servers, okay, and again, my size, it'll be the small, which is actually the default. If you notice in the load balancer, I didn't set the size because the default size for all of these templates is a small server. I could literally leave it just here, and they both say inherit from server template and inherit from multi-cloud image. That just means use a small 32-bit. I go with that. So what's my SSH key? Same one we used before. My security group, same one. Okay. Availability zone, any. I actually want them, since we're scaling a lot of these servers, I'd like to use any zone in the region, and that way if one region goes down, or excuse me, if one zone goes down in the region, I still have multiple other zones that are being used. So I'll leave that as any. And I'll click Array Details. Okay, so I want at least 2 application servers, but I'll say a max of 80. So minimum 2, can't go over 80. I'm going to go up by 10. So as I add application servers, I'm going to add blocks of 10, down by 1. Now this com time will make it scale up really quickly. Okay, so what I'm saying is, right, I have to have at least 2 application servers. I can have no more than 80. If you need to add them in blocks of 10. If you need to delete them because there's not enough traffic, remove them one at a time. Okay. Now, there are some things I need to do to this. The load balancer needs to ping the application server every 30 seconds to make sure it's still alive, because if the application server crashes, you don't want to send traffic to it. You want to be able to send traffic to the other application servers. And so I have to create a file on the application server that the load balancer can ping every 30 seconds. So I'm going to do that. I'm going to create what's called a write script. So I go to Design, Write Scripts. Okay, New. Now, I'm going to steal the content of this from one of our tutorials. So I'm at support.rightscale.com. By the way, there is a tutorial that everything I'm doing is in this one tutorial. And so it's down here under tutorials. It's called 3-tier deployment setup. So if you want to do what I'm doing in an hour, do this 3-tier deployment setup. So I'll click on it. And the reason I'm using it is because they've already written some HTML code, and then I don't have to bother writing the HTML code myself. There it is. Actually, right. And you can also see how we use a script. So this is, we'll call this, this is the health check. It's going to create a file for us. Right? And you can see it's actually doing is it's written in bash. And I'm actually saying create a file named hc.html and make that and put that file inside of that file, put some HTML. Here's the HTML. Actually, it's, in this file, we're just putting the word OK. Then we're creating a different file called servername.html file so we can go look at what's going on in the, see what server we're ending up at. OK, so I'm going to save that. Now I have a script that can add to my server template. So I'm going to take this script, and now I'm back at my server template. That's not my server template. There's my server template. This is my application server, and here are all the boot scripts, right? When this server boots, this is the process it's going to go through, every one of these scripts, to do all of its installation and configuration. So what I'm going to do is I'm going to add scripts to it. So I'm going to add a script, and that script's going to be, I wrote it, so it's under unpublished, and I gave it 915A so I could find it easily. There we go. Okay, and I'm going to move it up a little bit because it's a certain place I need that to be. All right, then I'm going to write another script, and this will I'll steal some PHP code that's in this lab as well. There. Okay, there it is. Now you may say, wait, didn't you put some PHP code in S3? And the answer is yes, I did. So I'm basically at the same time I'm showing you two ways to do this. You can write your own, or you can put it in S3. So create a new write script. And this will be called 915A. This will be create PHP app. Oops. There we go. Okay, so now I have a new script, and I'm going to add that to my server template as well. There it is, create PHP app. And I'm going to move it around because I want it to show up a little bit there. And I have one more thing I have to do is so I can find things from S3 instead of by default. So you can check things out from SVN, Git, S3. By default, it checks out PHP code from SVN. I'd like it to check out my PHP code from S3. So I deleted the SVN script. I added the S3 script. And now this server template is ready to go. Okay. Okay. I had to change the server template since I made changes to it. Okay. Now my server template's ready. Okay. I'm going to, this is my application array. I've got no running instances, but I'm going to create a bookmark just so I can get to it easily again. Okay. And I'm going to go, the other thing I'm going to do is give it alerts. I want to give it the ability to grow and shrink. So I'm going to grow array. Okay. And I'm going to put in here that when the CPU idle is less than 70, we'll say less than 30%. That means the machine is 70% used up. For 1 minute, I'm going to grow using the array as the instruction. So when the machines are, when all the machines or enough machines are 70% used up, then we're going to start adding more machines. Okay, and I'm going to create another one to shrink. So we'll call this one the shrink array. All right, same thing. If the idle is greater than 50%, and the machine is only 50% used, we're going to vote to shrink the array, also using that array as the instruction set. So now I have in the array the instructions on how to grow and how to shrink. Okay, right there. Okay. Now I need to go back and modify some more deployment inputs because I've just added a new server template, right, the PHP application server. So I need to hit the inputs on my deployment one more time. Then we can launch more servers. So first thing is the application code bucket. Where on S3 am I supposed to get this from? All right, so we go to Clouds, S3 Browser. And there it is, V2C app. All right, let's just click on it. So the name of the bucket where it's supposed to get this from is V2C app. And so we're going to put that right in there. The name of the code, the file actually, is this, myapp.tgz. So now my server can go into the right bucket and get the right file. How does it access Amazon? I'm going to give it my Amazon credential. Right here. Okay, so I've given it my credentials. The rest of these look pretty good. DB application password, right? That's another credential I created. Same with the user. Database schema name, I created a credential for that. See how easy it is when you create credentials? You can just choose them. You don't have to remember, gosh, what was it? And how did I spell it? And make sure it's the same on different servers. Just checking to see all the inputs are good. There's the op session stickiness somebody asked about. Right, by setting it to false, HA proxy will not send you to the exact same same application server every time. If I set it to true, you will get sent to the same application server every time. Okay, so I can save that. Great, now my application server has all the inputs it needs. Meanwhile, back at the ranch, we have some operational servers. Right? If we look here, we have 2 operational load balancers and a master database. Well, the master database is a running database, but doesn't have any data on it yet. We haven't told it to go into S3, get the database table, create the EBS volumes, and all of that. So I need to do that. I'm going to click on master database. I'm going to go into scripts, and these scripts have been provided for you. So I'm going to find a script that creates a stripe for us, an EBS stripe. So these are scripts that have been created because we know these are things you need to do. You need to do things like create database stripes, or you need to maybe, you'll see in a minute, we're going to change the IP registration of our master database. If your database fails, you need to promote your slave to master. It's not a big, huge, complicated process. There's a script that does this for you. Now what I'm doing right now is waiting because it's loading. So it's looking through all of the scripts with the word stripe in it to find the correct one. Okay, while that's happening, that's not right. Okay, let's try that one more time. Okay, we'll have to wait a minute for this for it to find the script. Let's try a different one meanwhile. Here goes my browser. So again, I'm in the master database. I'm going to look for a script in RightScale. Anyways, what we'll see now, these green boxes are showing the actual CPU. Because I've just told the load testers to send a ton of traffic at this website, in a few minutes, this where it says my app server, oops, down here at the bottom says 2 operational app servers. In a few minutes, that'll scale up. It'll go from 2 to 12 to 22 to 32, because I said go up by 10, all the way until it hits 80. Okay. Very good. Okay, and let's see if there's any more questions here. I'm reading the list of questions if there's any that I haven't answered. We have a limit on operating systems supported. You can right-scalize any operating system, pretty much. It's really what your cloud supports. And so we have like CentOS and Ubuntu and Windows 2003, Windows 2008. There's Red Hat Enterprise Linux. And so there's various operating systems that we support. But we give you the ability and instructions on how to pretty much right-scalize any OS. So you have to take the right-link component, you embed it in your operating system, and then you can use that. Because then you've abstracted from that particular OS, and then all your scripts and stuff can run on top of that, so you can still run your servers on pretty much any operating system. Question is, I'm looking at RightScaleTraining.com on my browser. Shouldn't there be a login? I don't think there is a login. It's just right. It's just a PHP page, so there's nothing to log into. If you go to RightScaleTraining.com/3tier.php, you'll just see the database. You can see some people have been playing around with it. That's great, right? That's your login /3tier.php. Fred Flintstone, Babe Ruth, I like these people, right? Albert Einstein, wow, Einstein's on my call. I like that. And let's see if we're getting some scaling action here. Yep, you're starting to see, well, that's in a slave. I'm going to run that script again. I may have run it too soon. There weren't enough load testers running. So I'll go to scripts. I will run the script, run on all. And run. Question is, are you using virtual or physical servers? We're using only virtual servers in the cloud. There are no physical servers. I think RightScale as a company owns like 4 servers just so we can do private cloud testing. I mean, really everything we do, this is all running in the cloud. All right. Okay, that kind of brings us to the end of the presentation. I'll leave this running for a bit, and we'll watch in a few minutes that the script, you can see here, the script over here running, and so we should see a lot of traffic, and then this number, 2 operational, will go to, from 2, like I said, it'll start scaling up.
Cool, Alon. This is Sarah. Thanks again, Alon, for a fantastic presentation. We're just throwing up a very final slide for you guys and want to thank you for your attendance. So this webinar has been recorded. We will be processing it this afternoon, and we will be loading it up on our site later tomorrow. So keep an eye out for that. I know this webinar was very fast-paced, but the recording is a great tool for you to use to review anything that you may want to cover again from Alon's presentation. So if you'd like to contact RightScale, our information's up here on the slide. Also links to some more information if you'd like to read our webinars or, if you'd like to read our white papers, check out some recorded webinars, or even sign up for the RightScale free edition. So also just want to point out the final webinar in our webinar series is coming up next Wednesday, September 21st, The Fast Path to Private Cloud, with our CEO, Michael Crandell, and then also James Staten, who's a principal analyst at Forrester Research. You definitely will not want to miss that one. If you're not registered already, there's the link right there. Also the link for our RightScale conference coming up in the beginning of November in Santa Clara. We would love to see you there. You can also have an opportunity to meet Alon in person. If you have any other questions, we're going to keep the webinar open for a few more minutes. Alon, if you want to pop back over to your screen so that people can actually see the scaling happen. It's kind of exciting. We'll just keep watching that. But otherwise, if you have any questions, ask away. Otherwise, thanks so much for coming, and we'll see you in a future webinar. Bye now.